Let A be a square matrix. The minor of entry A sub ij, denoted as capital M sub ij, is the determinant of the matrix left over after eliminating the ith row and jth column. For example, consider the following 3x3 square matrix A. What is the minor of entry A sub 1, 1? A11 is in row 1 and column 1. The definition tells us to drop the row and column associated with our entry, so we imagine row 1 and column 1 disappearing. The minor M sub 1, 1 is then the determinant of what is remaining. The minor M sub 1, 1 is equal to the determinant of A22, A23, A32, and A33. Basically just what's left over after crossing out the row and column of our entry. This is a 2x2 determinant which we can evaluate using this guide here. M sub 1, 1 is equal to A22 times A33 minus A32 times A23. Now this was the minor for A11. There are 8 other positions in this matrix, each of which have their own minor. The minor M sub 1, 2, we cross out row 1 and column 2 and take the determinant of what remains. M sub 1, 3, we cross out row 1 and column 3 and take the determinant of what remains. For the minors of the entries in row 2, we cross out row 2, drop each of their respective columns and take the determinant of what remains. The minors of the entries in row 3, we drop row 3, drop each of their respective columns and take the determinant of what remains. We could then calculate the 2x2 determinants using this guide here. So these examples are all using arbitrary elements for our square matrix A. Consider this square matrix A where we have numbers within our matrix. What is the minor M sub 2, 2 here? The first index was the row, the second index was the column, so M sub 2, 2 we get by crossing out row 2 and column 2 and taking the determinant of what remains. M22 is equal to the determinant of 1, 5, 6, 2. This is equal to 1 times 2 minus 5 times 6, which is equal to 2 minus 30, which is equal to negative 28. M22 is equal to negative 28. Take a second to calculate the minor M31. Well, the 3 is the row, the 1 is the column, so we cross out row 3 and column 1, and we take the determinant of what remains. Using the 2x2 determinant guide, we get M31 is equal to 7 times 8 minus 3 times 5, which is equal to 56 minus 15, which is equal to 41. Once again, to find the minor of an entry in a square matrix, we cross out the row and column of the entry and take the determinant of what remains. Check out the related video if you want to continue learning about minors within linear algebra. If you found this content helpful, consider subscribing, commenting, or liking the video to support my channel. I'm Joe, and thanks for spending some time with me.